I've seen this before. It's about the compiler. Potentially there is some issues here that I need to, or some settings that I need to change. So if you know, I would appreciate a lot to let me know. Maybe write it in the comments. But I wanted to mention that I always check out the Pragma versions because it's common to find the projects that they are using either, well, different versions and also they are using what is called the floating pragmas with this thing. Okay, it's interesting that this fixes the error, but it makes sense because I think the error was saying, yeah, of a higher version. So nowadays, at this stage, the scripts, the robots that are running by some of the people are detecting these issues. So it's good for you to know, and I'm going to mention those things. But yeah, I know this is going to be. Well, I don't know back in the time of this project if it was handled, but anyways, nowadays it's not worth to report because it's handled by those. Let's go further. Uh, Kuma access controller. So this was handling other roles. I can see that in the constructor. It is extending access control. And we have a default admin role and a Kuma manager role. I'm wondering where they are, or if I can find any more information about it. In access, yeah, probably they are in access control. Let's see, since we're here, let's see what we can find. By default, the admin role for all roles is that one, which means that only accounts with this role will be able to grant or revoke other roles. Okay, I can see at least it can be changed. Apparently, the set role admin. A warning is also, default admin role is also its own admin. It has permission to grant and revoke this role. Interesting, okay. Like only owner kind of permissions. Extra precautions should be taken to secure accounts that have been granted it. Okay, so more than one account. Okay, interesting. It's initiated to 0 address. Okay. I'm not sure if I should go through this smart contract now, but let's take a quick look. Maybe we'll come through this later, but it has some modifier for only role and you specify the role. And then it will probably go further and compare. Yeah, it has to decode it. Access control account. Okay. Has role. Yeah, this smart contract seems to be taking care of those verifications. Okay. We might go further. Oh, you see this? What I mentioned? I knew that. They are commonly using, or it's common to find this, that there are different versions used. That's worth reporting because, like, for instance, even in a private audit, it's worth reporting for sure because it's not safe. Okay, so what we can see here is that it's granting both roles to the person that or whoever is deploying this contract. Sometimes I like to go and check the test cases. Actually, look at that. Base set test, base setup. It's probably going to deploy it somewhere here, but yeah. Anyways, wanted to mention that as well. It's curious. I'm curious sometimes to just come and check. Although I don't base it, I'm not sure about that. I will not take a look right now, but yeah, I think it's good to go and switch through the test while we're trying to understand what's happening in the protocol. At the moment, yeah, it's too early to check for me at least. I'm not sure what's going on, so let's try to find out more. Let's see which other smart contract we can be checking next. Probably let's go next on the surprise, it's access controller. Oh, okay, but from MCG, you know what? Let's stick with Kuma protocol. I think it makes sense. The next is, yeah, we'll do it separately. Next is KBC token. Where was it? Sorry. Okay, yes, here somewhere. Here it is. Did I write something? Okay, never mind. KBC token. In this case, what we can do before going through it is what I mentioned earlier. Let's go back to the documentation And now we can read about it before starting to analyze the code. Let's see if there is a section specific for it. If not, let's see, maybe it's, what was it standing for? Yep, no, KIB. KIB, maybe here we can see. One is KIB token and this is KBC. Okay, it must be this one for sure. Kuma Bond Clone Token. KBC token, yes. Let's see. When the central bank rate drops lower than the current KIB token yield, clone bonds lower the coupon of bonds that were bought by users from Kuma swap contract. This ensures that at any point in time there are enough KIB tokens in circulation to buy all the bonds from Kuma swap reserve. The lowest paying yield corresponds to the lowest yield between the central bank rate and the lowest coupon in the Kuma swap reserve. And there is more information. Let's see. Just reading it from top to see if there's something that catches my eye. Since the 5% bond appreciates more quickly than the KIBT total supply, blah 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 blah. A clone bond is always paired with a parent bond. I'm curious to find out what's that bond in the code from the reserve, and will have a lower. It's like a pair from like Uniswap when the bond is valued. For each clone bond present, the parent bond cannot be redeemed by a user and can only be redeemed by the MCAG multisig. KBC token can only be issued by KumaSwap in the buy bond function. Okay. Clone bond coupons are only created if the bond's face value is greater than that of the amount of KIBT. Okay, let's go back to the code. I need to read more of this. Okay, we're probably going to define this in constructor, but I can see it uses initializer, which is probably using upgradable. So this upgradable contract. This is a bit weird that it's. I'm not sure if I recall seeing the constructor being called. You know what? We can do something. Extend. I'm wondering about the constructor. If it needs to be initialize instead of constructor. Let's see what we find. What we find here. Okay, here you can use utility contracts except for their constructors. Due to a requirement of the proxy-based upgradability system, no constructors can be used in upgradable contracts. Okay, so that seems like an issue. Not sure what's the cause, the problem of having that. Let's see what can we find out more about it. Okay, there are some reasons in proxies. This means that when using a contract with the Open Zeppelin upgrades, you need to change its constructor into a regular function, typically named initialize. So we had the initialize there function, but we also had a constructor. That's what didn't look right. See, we don't have here. Okay, I'm going to mark it for now. We will be, if it's an issue, we will be seeing it later. Yeah, let's do that. Let's go back. You know what? I will also, so that you see, I would in this case mark it if I wouldn't have the answers, let's say, the report. I would, since we are doing an overview, I would just mark it, like I would say, should not add constructor. And I will be going back to that afterwards. In this case, we're just going to go to the report and we will find out there. But yeah, that's a way of keeping track of it. And this is the plugin. What was it called? Do I have it somewhere here? Inline bookmarks, I think. Yeah. You can add audit info, audit issue, audit OK, and audit. That's very useful. So yeah, if you know it, now you do. So in this constructor or initialize, we're passing probably the address or the contract address of this, address provider, checking that it's not address 0 or reverting. Okay, let's go further. Issue bond means a clone bond NFT to the specific address. Can only be called under specific conditions. Okay, mint role. And probably it should be doing some verifications about it. Okay, here it is only Kuma swap, which I understand will have that mint role. Can we take a look? Is it somewhere? Oh, it was on top. Risk category. Okay, that's something I don't understand yet. But anyway, some verification to make sure it's the right, it has the right access, the right person. And we're minting with this apparently, yeah. Token ID counter. Okay. This is just, okay. The ID is basically incrementing probably from 0. That's the ID that is passing. And the C bond, clone bond struct, storing metadata. Okay. Not sure, but let's go on. Redeem. Okay. So one for minting, another for taking it out, right? Burning. Exactly. Minting, burning. Getting com address, get bond, clone bond ID. Bond struct storing metadata of the select bond ID. Do they have any? What do they have there? What do they have here for bond? Oh, that's a lot of things. Bond, bond. Selling bonds. Okay, we're going to understand a bond as that's for now an NFT. Well, it is what it is. That's what it is. But yeah, authorize upgrade. Okay, in general, we know that this class, it is extending, it's upgradable, and it is minting and burning overall, and it has some permissions. And let's see what's the next contract. A clone NFT token that is issued when the KIBT yield is not high enough to buy back the original bond NFT. Okay. MCAG, protocol again. Now, MCAG rate feed contract that reads the price from the MCAG central bank. Okay, let's take a look then. Let's see. UUPS upgradable. Open Zeppelin. I honestly don't know that. Can I see it? Yes. There's the top, yeah. An upgradability mechanism designed for UUPS proxies. What are UUPS proxies? Let's find out. UUPS proxies are implemented using an ERC 1967 proxy. Note that this proxy is not by itself upgradable. It is the role of implementation to include alongside the contract's logic all the code necessary to update the implementation address that is stored at a specific slot in the proxy storage space. And if we Google this, ERC, a proxy using EIP 1967 storage slots not upgradable by default. And this, okay, not upgradable by default, so there are two alternative ways to add upgradability to an ERC 1967 proxy. Transparent upgradable proxy and UUPS upgradable. An upgradability mechanism to be included in the implementation contract. Okay, so I understand that this contract might be an ERC 1967 or part of that proxy, or maybe in this project, and by adding this, we're making it upgradable. Okay, what is the difference? Oh, this one also had it. Okay, let's go on. Yeah. We have some constants, minimum rate coupon, and some decimals probably for the token. Okay. Only manager, so managing the roles. We have the same here. Okay, we have it marked in the first one. No need now to mark it again. Initializing. The initialize function, of course, is the one that it's running when it's deployed. There is this thing I discovered a while ago. Wait, it has the initializer, yeah. Probably this what this initializer, yeah, it needed to extend this. This initializer it has some checks in there. Probably was coming from this initializer. Is it implemented here? Ouch, did I jump it? Oh, here it is. A modifier that defines a protect initializer. Anyways, the thing is that those that are upgradable contracts need to be going through this logic. You can take a look at that separately, but yeah, that's that's a thing I learned that it's important. I actually have it in a tweet on my account, but yeah, and I actually made a thread about it. Yeah. Anyways, that's good. It's there. Let's go on. Okay, we're setting an oracle. Set an MCAG aggregator for a specific risk category. So probably this was a kind of bank, right? So it's might be off chain, I guess, if there is the need to set an oracle. There is no need for staleness check as central bank rate is rarely updated. Okay, yeah. So it's probably just to check the rates. Okay, that means that we need to make sure there is no issues with the oracle. Okay, that could take us to, in these cases, you would, of course, we're going to continue checking, but when you want to go deeper, you would go to Sol Audit and check about oracles exploits and so on, because yeah, there are some things that you need to verify always. But yeah, we're not going to try to understand all the logic here. As I say, this is not I mentioned at the beginning, we're not going the full audit here, and anyways, at the beginning of an audit, it's better to do an overview, know what it's around, and then it's when you go deeper and try to dig deeper there, everywhere, understand everything, yeah, more specific. Get rate, yeah, so this is probably just to get the rate from the Oracle. What else we have? Get Oracle and other stuff. Cool. One down. Let's close this and this. Okay. Yeah, feed. Yeah, definitely that. Raise the price from the central bank. Great Oracle, it was mentioned there. What's the next? Kuma address provider. Address provider, I've seen that before. Yeah. Address provider that stores the mappings. Stores. Kuma sub and Kuma fee collector for each risk class. Okay, let's take a look. Kuma address provider. What opens up in? Yeah, okay, it's upgradable like potentially all of those, but we'll see. Okay, some mapping here. We'll see what this is about. Only valid address, another check. Probably will be okay. That's a nice way to not repeat the code. Yeah, will be. It's checking probably in all the functions here that this address passed. It's not zero. That's a good way. Let's go back. I've seen that before. Initialize. Okay. Okay, we're setting KBC token. I think we read somewhere that it was this contract is handled by address provider. So that's probably what's happening here. Setting the KBC token. That's defined on top. Okay. Probably reused somewhere else. We'll see. Probably this made so that whenever it gets upgraded, it would change the address. So if you would hardcode it here on the top and make it a constant or similar, then yeah, it would not be ideal or might not be even possible to change it. But yeah, let's see. Set rate, setting Kuma bond token. Okay, similar thing. And KIB token. We can see here some other logic. I don't know that yet. Let's see if we find out later. What else? Satkuma fee collector. Okay, yeah. Apparently there are some fees about it for sure. And some getters. Usually in the getters you want to check this part that it's a view. And of course external. Because that way it's probably taken by other contract for sure. Get Kuma swap and check risk category. That was here. Yeah, in set Kuma fee collector. Okay. Okay, some other decoding, some other code here. Yeah, because we're passing bytes, so we would need to take it out with a VIN code. Okay. So this contract it's doing mainly, I think it's well setting or defining some of the tokens that are in this in Kuma protocol, handling that. Yeah, setters and getters here. Okay, we've got that so far. What else? Kuma fee collector, Kuma fee collector. Let's see. That's the role. Initialize, release. You know what? Let's see if we can find something about a fee collector here. Of fees. Nothing here. Of fees. Okay. Okay. Release. Releases the accumulated fee income to the payees. Okay. Makes sense so far. Okay. We're probably getting the balance of the KIB token. I keep saying Kai. KIB token. We didn't go through it yet, right? No. Okay. But it seems it's cutting the fees, I guess. Okay. Available income, 0. Repaired. What probably we're really... Oh, there is an internal function. So here it's handled some checks and then we go to the internal. If we can go directly to that so we don't lose context. I want to see it's going to be in this same class. That's for sure. Okay. Internal helper function to release an available income to all payees. Uses total shares to calculate correct share. That's the address of the token. Available income that we passed before. That we passed. Oh wait. That we passed here. Available income. Okay. If we were to improve the gas thing, we could mention this, but that's very little thing, and everyone knows it anyways. So it's going through all the payees that must be defined on the top. I don't remember it. Oh, it's probably a set of addresses. Those, I guess, that are involved in any swap, probably. Let's see if I can go back where I was. Release. Okay. And it's transferring to them probably their shares. Total shares. Total shares. This could be when I see division like this, I would first thing that comes to my mind is possibility to be divided by 0. So I'm wondering if at any point that can happen, that would revert the transaction. So we can track it a bit also in the file. What's its path? So it's obviously defined there and not just privately, and it's increased when we add a payee. So it's never going to be 0. Is it? I guess it. Okay, let's go back to the release. Yeah, I guess you will not release if you never added a payee. So yeah, I guess it's probably fine anyways. And it's not like, well, I don't know if we can remove them, but we'll see. Okay, so that's basically release doing. So far we are. Okay, let's then go back to the beginning because we have seen the release the first function. Yes, add payee. So we'll update total shares and therefore reduce the relative share of all other payees. So that means that needs to be doing some logic here. Okay, let's go on. Oh, so we can remove payees and it's external, but only manager can. Okay, so cannot be or should not be manipulated by everyone. That's good. Let's go on. Function update payee share. Okay, updating, yeah. Probably reducing or decreasing, yeah. Update. Increasing it or decreasing. Makes sense. Change payees. Okay, but you can change the list. Okay. Okay, there's some logic there, but let's go on. Release if available income. We're executing the internal release anyways. Okay. Next. Oh, here it is. KIB token. Here you are. Let's see what's in here. ERC20 permit upgradable and of course UUPS upgradable like all the rest. Okay, initialize. Set epoch length. Okay, not sure what's epoch. I don't know if I've missed this. Rebase intervals in seconds. Okay. Okay, anyways, we can set it here. What else we have? Refresh yield, update yield based on current yield and Oracle reference rate. Alright. And we're minting. It's overriding. Okay. Log timestamp dash refresh. Okay. Updating the balances. And of course, if we're minting, well, of course not, but we're burning as well. Yeah, I'm not gonna go through the logic, but there seems quite a lot of it. Some getters, getting the total supply or transferring. This might be interesting to look closer. If the balance is less than the amount, of course, don't transfer it. We are doing the actions here. So is check, interaction, okay, some calculations. I'm not sure what's converting. Okay. And is it transferring here? Where is the transfer function? Okay, I think this check, I would add it more on the top because if it's zero, then you could have avoided that logic, but total base balances. And then we're emitting the transfer, but I didn't see do you think the transfer is somewhere here? It's not. What about here? Well, I'm not sure. I don't see it. But yeah, might be very obvious. I'm not saying it. But yeah, let's see. I might come back to this or we'll see later. Alright, let's move on. Refresh cumulative yield updates the internal state variables after accounting for newly received tokens. Okay. Calculate previous, calculate cumulative yield. Some verifications. In general, these checks are usually in the docs, and that's what once you go deeper in the code, you would go there, read what it's mentioned, and make sure it applies in the code and it's properly noted. For now, as I mentioned, I will be doing just the overview and then go to the bugs, but let's see, I would expect also feedback from you guys if by any chance you feel it would be or it's not helpful enough or you'd rather have a second part or something like that, being more specific. But I guess since we're going to check the bugs later, I think this series of videos should be right to do the overview and the bugs check, the reports check. But yeah, again, we're just trying to get familiar with it so we can understand better the issues. We're refreshing the yield. We're getting the contract Kuma swap. I think we're going to check that later. Again, some checks that is not expired or deprecated. Getting some information and verifying it. Okay. Probably those are just used okay, here. In one of the above functions I wanted to say. But yeah. Calculate previous airport cumulative yield and authorize upgrade. Let's move on. Where am I? Here. So I think the last one and biggest is Kuma swap. I think since we read here that's the main contract. Yeah. Let's see what's there. Let's see what we find. Okay. It's extending its interface. Possible upgradable. What is the possible upgradable? Let's check, because I'm not sure about that one. Contract model which allows children to implement an emergency stop mechanism that can be triggered by an authorized account. Okay, let's see. This model is used through inheritance. It will make available the modifiers when not post, when post. Okay. I expect to see that in the code then. Note that they will not be possible by simply including this module only once the modifiers are put in place. That makes sense. Okay, let's see. This kind of library, I guess, for maths. Let's see, let's go on. Set unique coupons. Set all tokens IDs. Set all expired token IDs. Kuma bond token ID to... Okay, that's a mapping. Quantity in reserve. Bond ID to bond sale price. Oh, here we can see, when not deprecated on our modifier. When deprecated, initialize. Okay, verification of the address, passed. This one, and this one. What is this? Maximum coupons. We have them defined here. Yeah. Okay. So let's see. First function here we have sell bond. Sells a bond against KIB token. What are we doing inside? Some checks. KIBT. What are we going to do with it? Reference rate. We're getting from the Oracle, I guess. Okay. Minimum coupons. It's basically doing some verifications all the time of the invariants probably, that everything is as it should. What else? Yeah, okay, we're minting with the sell bond. We're minting the KIB tokens to the message sender and transferring it to this address. Okay, to this contract comma swap. It's keeping the tokens. All right, by bond. So probably a lot of checks again and burning. So we sell, we mint, and if we buy, we burn. Okay, I will stay with that for now. Okay, there is another situation where it may do the transfer back to the if required clone. What's this? If the bond face value is major than realized bond value. And realized bond value comes from, okay, here it is. Required clone or not required clone. This would be important to double check this amount and make sure it's as it should, because it seems very important here, actually. For now, again, we're just skimming through it. Okay, buy bond for stablecoin. Buys a bond against deprecation stablecoin. Requires an approval on amount from buyer. This will also result in some stale state for the contract on coupons and main coupon, but this is acceptable as the deprecation mode is irreversible. This function also ignores any existing clone bond, which is the intended behavior, as bonds will be valued per their market rate of change. Okay, buy bond for stablecoin. We're removing the tokens from the reserve. I'm wondering if we can read a bit more about it, because didn't get much from that. One known limitation of the about deprecation mode is the fact that the manager role can spend the buyer's allowance in the buy bond for stablecoin function. Okay. Oh, this is the bond, look. It's on the struct, I have probably missed it somewhere. It has all these parameters. Okay, let's go back. Okay, yeah, as you see, we're doing the checks, we're removing it, and then we're sending. Yeah, that's good, that's protected with a check. How was it called? Check interaction actions? Something like that. For reentrancy wise, to be protected, even though there is no modifier for reentrancy, but this is a good practice. Claim bond. James Bond. Okay. Claims a bond against a clone bond. Can only be called by Kuma swap claim role address. Okay. Only role. So this is not for every user, but for the owners. Okay. And what are we claiming exactly? We use redeem from KBC token contract. Redeem was burning? Yeah. So by claiming we're burning the KBC tokens in the Kuma swap claim bond function. Okay. Burning and then sending that token ID, Gbond ID. Okay. We're halfway this contract. Redeem KIBT. Redeems KIBT token against the application mode stablecoin. Redeem stablecoin amount is calculated as follow. Okay, do we know where is that calculation here? Okay, this is it, I guess, yeah. and it's multiplying before dividing. That should be the right way, and that's the library used. Okay, what else? What do we do with this redeem amount? We're transferring it through the deprecation stablecoin contract before burning it. We're burning the amount and transferring redeem amount. Okay. Why this amount is in this operation? It's KIB. Yeah. Okay. Probably it's KIB token amount. So this parameter, isn't it? I hope so. All right. Expired bond expires a bond if it has reached maturity by setting min coupon to min allowed coupon when not deprecated. It's external. That's a bit odd that it's external. If you can expire a bond, anyone can? Really? It's not checking who is running this. I don't know if this can be an issue here. I'm still not sure what's this supposed to do, but what's the main action? We're adding expire. See, in this case, it seems like a proper place to add another tag. There is no access control, I'd say. Well, access control is external. Maybe no role control. Let's leave it like that. No role control. Let's see later if there's actually something with this. Oh, and remember what it was mentioned about the pausing and unpausing. It comes from pausable, upgradable. Okay. Setting fees in swap. Set deprecation stablecoin. Sets a new stablecoin to be accepted in deprecation mode. I want to read something about the deprecation mode. KIBT is minted and burned such that the total supply is always sufficient to buy out all the Kuma Bond NFTs held in the contract. However, in extreme cases, some of the KIBT supply might become inaccessible if large amounts of KIBT are hacked or lost to unknown addresses. This could result in Kuma Bonds NFTs being locked in the Kuma Swap contract. To mitigate this scenario, the DAO can vote to put Kuma Swap contract in deprecation mode, where users can buy bonds with stablecoins through voted on parameters. It's like a way out mechanism, apparently. Since there is a unique Kuma Swap contract for each risk category. One deprecated Kuma Swap contract for a given risk category does not impact other Kuma Swap contracts. Okay, and this one is activated. Okay, let's go back to the code. Oh, here we're initializing it in Kuma Swap. Okay, what else? Get risk category. I mean, here I didn't mention anything. Enable deprecation mode, but for now the idea is clear. We're enabling here. We're dealing with the deprecation mode here. And some getters might be, the rest of it might be getters. And some other checks. It's an use function parameter. This is a callback. Okay. This is the callback function from ERC 721. So I guess it's normal, it's not used. Okay, and yeah, it always needs to return that selector. Or at least, yeah. Maybe some other logic, but at least that selector. So that's good. Update minimum coupon. I'm not sure we found out what are the coupons here. The Kuma subcontract won't allow users to sell bonds to the contract which have a lower coupon. Is anyone explaining those coupons? Oh well, not exactly. Okay, here. Annual interest rate paid on the bond per rate per second. Okay, interest. Okay. And some actions unchecked. Okay. Nice gas optimization here with unchecked calculating fees. Something I learned about a way to improve the gas optimization of this is usually that this is more expensive than adding this, for instance, like that. This is cheaper. like that. So that's another possibility, but I'm sure nowadays it's reported by the bots. I said robots earlier, but yeah, I guess bots is better. Properly used. Were we at the end already? I think so, yeah. Okay, so we have all Kuma protocols. We're quite a while here already. 1 hour and a half, I think. Let's see. I'm wondering it might be worth to jump to the report already. It's probably yeah, those are in MCAG contracts are connected with the external bank thing, the Oracle and so on. Let's see, KYC token. We could check that quickly maybe, but that's the connection with the Oracle most likely. We have that one, KYC token, Kuma bond token. Okay, that's also important actually. You know what? Okay, let's take a look. The KYC. Let's go to the KYC. Let's close this. KYC token. Here you are. Should we read something here about KYC? KYC tokens. KYC tokens are non-transferable ERC 721 tokens minted to a specific address only after the owner of that address has undergone and now your customer. Okay, so it's literally okay. Good to know. So definitely it seems this protocol requires that KYC verification. Okay, that makes sense. That's why it's called KYC. For those in case you don't know, that's where you need to identify yourself, basically by providing ID and what other kind of identification, so they can assign your address to someone. Okay, let's leave it there. That's good enough information. What's happening here? Let's see. Mapping token ID to KYC data. What is this? KYC data. Can I see that? It's probably abstract, yeah. Okay, good. Let's go back. This is not upgradable, for instance. That's why we see the constructor and not initialize anymore. Okay, we're passing the access controller address, I guess, of that contract. And we have a function for minting using safe mint. Using safe mint has a trick because it has this callback. I'm not gonna check it now, but I know it's probably covered, but worth checking, you never know. Check for callback. Because safe mint has something. Can I enter that? Okay, no. Oh, it's here anyways. Safe mint has mint and has this check on ERC 721 received. I think we've seen that being implemented in another contract. I don't remember now, but yeah, it's basically going to a callback function. It's going to enter the smart contract that called it and look for the function on ERC 721 received. Oh yeah, and if it's not there, most likely it will fail. It will revert. Okay, let's go back on track. So we're minting, we're burning, setting URI. Okay, some getters, proof. Approve not used any parameter. Token is not transferable. So it's probably, it's overridden to make it not transferable. Okay, that makes sense actually. That's interesting to read. It makes sense for the KYC token. I'm wondering if it's not implemented this size token somewhere where it can be reused. KYC token, most likely not. But yeah, could be interesting to Google it. I won't do it now, but yeah, feel free to check it. Might be interesting to find out. I might do it later. We're not transferring, okay. So we're overriding it so that it's not allowed in case of being called. Okay, that's good. How's the next contract from this folder? We have KYC token, Kuma bond token. Let's check that one. Kuma bond token. Wait, It's also ERC 721, it's possible, and implementing this interface. Okie dokie. Not okay. Here there is a whitelist or blacklist, apparently. More blacklist. So not blacklisted. I guess it's a whitelist. Throws if argument account is blacklisted. So if it's blacklist, it would not continue. It would revert. Okay. Got it. Constructor, defining the NFT parameters. Okay, issue bond means a bond NFT to specified address, this address. And we're using safe mint. And we have a routine for burning. Okay, similar probably. And is it transferable? Apparently yes, but we're still overriding it anyways, changing the logic. Okay. So basically it's adding this extra verification apparently, in case it's not handled, and running a proof, the internal one. Okay, this is transferable, we've got that, it's just adding some extra information. Sorry, verifications. Okay, so that will be it.